Hello guys, good morning. You are welcome to my YouTube channel on the Explicit Tutorials. As you all know, I'm Sir Joseph or Mr. Explicit. Please, as you watch this video, endeavor to subscribe, like, share, and comment. And secondly, if you know I'm preparing for 2024 UTME, Post-UTME, NECO, GCE, NAPTEB, WAEC, nursing exams, please just chat me up on this number 091 60 11 53 75 so that you can be added to my WhatsApp group because lectures have fully begun on the group. Don't forget, endeavor to chat me up. Let us kill physics, chemistry, biology, and mathematics together. Okay, look at what we have on the board: chemical and physical changes. Do not forget that in our previous class we did treat pure and impure matters, all right, and the impact of impurities in solid and liquid, all right. We established that when impurities are present in a given solid, all right, such impurities will cause a depression or a decrease or a reduction to the melting point of such what solid. However, when the impurities are present in a given liquid, what happens? They cause elevation or an increase to the boiling point of what? Liquid. However, there are certain stubborn mixtures that would neither decrease nor increase despite the presence of impurities. These mixtures are called azeotropic mixtures or constant boiling mixtures. And I also told you that these mixtures are best separated through fractional distillation or azeotropic distillation. Example of such a mixture is ethanol or alcohol and what? Water. And we also said that hydrogen bond is responsible for the high boiling point of what? Ethanol, and that is 78.3 degrees Celsius. And we said that hydrogen bond is also responsible for the abnormalous behavior of water. Water freezes at 0 degrees Celsius and boils at 100 degrees Celsius, right? Those are that's one of the features of water, okay? It boils at 100 degrees Celsius and freezes at 0 degrees Celsius. Apart from that, we also established the various states of matter: solid, liquid, and gases. We said that when solid changes to a gas without passing through the intermediate liquid stage, we call it what? Sublimation. Okay. We also gave some examples of solids that exhibit such phenomenon. We said naphthalene, benzoic acid, quinine, toluene, dry ice, that is carbon 4 oxide. Of course, carbon 4 oxide is used as fire extinguisher, okay, because it does not support combustion. Of course, carbon 4 oxide is also used as preservative in soft drinks and also gives them their fresh taste, their refreshing taste. Okay, now why is carbon 4 oxide used as a refrigerant? It is used as a refrigerant because it changes from solid to what? Gas. Don't forget, it is used as fire extinguisher because it does not support combustion. Of course, normally carbon 4 oxide ought not to act as a pollutant, alright? But it becomes a pollutant in the environment when it occurs in excess amount. It becomes what? A pollutant. Of course, to an extent, it contributes to the depletion of the ozone layer. You know, the ozone layer is an artificial shield that prevents excess ultraviolet rays from reaching the Earth's surface. The ozone layer is also called ozonosphere. Alright, take note of that. And it is found in the troposphere, under the atmosphere. You know, the atmosphere is divided into different layers: troposphere, the mesosphere, the thermosphere, and whatever. Alright, but the ozone layer, which is called the ozonosphere, is situated in the troposphere layer. So that is what we have it to be. Apart from sublimation, we also said that the various state of matter can change from one form to another, all right? Like freezing, melting, condensation, vaporization, desublimation, or deposition. All of these we established in our previous class. So in today's class, we'll be treating chemical and physical changes. In stating what a word is or what a term is, we focus on the salient points said on the definition, not about beating about the bush. Just give the salient or the central or the rudiment, then you are good to go. What is a chemical change? A chemical change is a change that is irreversible. That is what? Irreversible. That is one of the points that make up chemical changes. It is irreversible and new substances are formed. New substances are formed. Did you see that? New substances are formed. That is not all right? It requires large amounts. It requires large amounts of what? Heat. We aren't done owing to the fact that it is irreversible and new substances are formed. All right. It therefore connotes or denotes that the mass, there is a mass of the substance, the mass of the substance changes. The mass of the substance changes. That is, it does not remain the same. So these are the 4 points that are needed in stating what chemical changes are. Chemical changes are changes that are irreversible. Alright, once they change from their initial state to another stage, they cannot be brought back or they cannot be reversed to their initial state. New substances, of course, are formed. Large amounts of heat is needed for it to change from one form to what? Another. Then the mass of the substance changes. It does not remain the same. Now the question is, what are some examples of chemical changes? Please, number one, Jam loves this question so much. All right, the addition of water. The addition of water to calcium carbide is what type of change? Calcium carbide. The addition of water to calcium carbide is what type of change? It is a chemical change. In fact, the addition of water to calcium carbide, is one of the methods of preparing ethane, which is a colorless gas. Of course, ethane is also, it also supports what they call what? It's used as oxyacetylene flame. All right, oxyacetylene flame, because the ethane, there is ethane, or I can say the alkyne. Alkyne is also called acetylene. All right, acetylene. Okay, and of course, apart from the what about the alkane? Alkane is also called paraffin. Please take notes, paraffin. Then alkene is also called olefin. All right, so please take note of that. All right, ethane is used as what? Oxyacetylene. Then you ask, which of the following is used as oxyacetylene flame? Of course, it is what? Ethane. So the addition of water to calcium carbide is a chemical change. Let's do the illustration. So if I have this calcium carbide plus water molecule, which is H2O. If water molecule is added to calcium carbide, it will produce ethane and calcium hydroxide. I said this is one of the methods of preparing ethane. Is the equation balanced? Let's check. Let's look at it properly. So we have 2 carbon, right? One calcium is balanced. Then also we have 2 hydrogen atom here. 2, but we have 4. 2 plus 2, 4. So it means we have to place 2 at the back of this place, okay? Then how many oxygen? We have 2 oxygen, so we have 2 oxygen. So the equation is what? Balanced. So the addition of water to calcium carbide is a good example of what? Chemical change. And number 2 is neutralization. Neutralization is a reaction between an acid and a base to produce salt and water only. I'll take it again. Neutralization reaction is a reaction that occurs between an acid and a base to produce salt and water only. Take note of that. And there is a reaction between an acid and a base to produce what? Salt and water. So from this reaction, if I should carry out this reaction scrupulously, we have Na2SO4 plus what? H2O. It is a reaction between an acid and a base to produce salt and water only. But the equation is not balanced yet. So in order to balance it means we have to place 2 at the back of this place because of this what? 2 sodium. So I think with this, the equation should be balanced. No, it's not balanced, okay? So I will have to place 2 at the back of this place, and of course that automatically balances the equation. 2 plus 2, 4 hydrogen, right? Because these 2 affect everything here. 2 hydrogen plus 2, I have 4. So 2 times 2, 4, right? So the next one is sulfur, 1 sulfur, 1 sulfur. The next one is oxygen. 2 oxygen plus 4, that gives us what? That gives us 6. Then 4 plus 2, that gives us 6. So the equation is what? Balanced. Neutralization reaction is a reaction between an acid and a base to produce salt and water only. Alright? So apart from what I just illustrated, I can also have it to be H2SO4 plus, that is this potassium hydroxide, right? Then I'll have H2SO4 plus what? Water. So it means I'll place 2 at the back of this place. So this is a neutralization reaction, right? You can also by yourself react HCl. You know HCl is an acid, okay? React HCl with sodium hydroxide. React HCl, sorry. Yes, hydrochloric acid, alright? React this with this, an acid, a base. React it, you'll be having sodium chloride and water, alright? When you react it with this, you'll be having what? Potassium chloride and water. If you should also react aqua fortis, HNO3,